Welcome to Shift Testing Left to Build in Quality. Hello, I'm Ken Pugh. So what are the tests for this session? Well, these are also known as objectives. Describe how Shift Testing Left helps build in quality. Identify how loopbacks are reduced by Shift Testing Left. Identify the different aspects of Shift Testing Left. And finally, describe the collaboration in Shift Testing Left. So here's my overall rule. There are exceptions to every statement except this one. And what do I mean by that? When I say you always ought to do something, I don't mean always, but usually always. And when I say you never ought to do something, I don't mean never, ever, but usually never. And I have a second overall rule. Context is everything. Everything exists in a context. And everything is always true in some context. Take an example of Netflix. They do 15,000 deployments a day. But on the end user standpoint, if the video stops working, all they do is reload it and they're connected to a different server and everything is right. But if you're a financial services institution and somebody's making a stock purchase and it goes wrong, well, you've got a disappointed customer and a regulatory agency to get referred to. So everything always exists in a context. So let me introduce what is built-in quality. Well, it has two aspects to it. Building the right thing and building that thing right. So let's take a look. Typically what we do is write a feature and then write a story and write code. Okay, that's the way we do it without shifting testing left. Then finally, we do test, figure out we need to test the code. Then we figure out, oh, I better write a test for this story. And then you go, oh, I guess I got to test the feature. And now what do you get? It's a V. And this is called the traditional testing or V model. And what happens when you do things like this? Well, here's a flow. You decide you're going to do something, you analyze the requirements, you design, you do some coding, finally go, I guess it's time to test. And you start running all the tests, then you deploy it to your staging, and finally execute it in production. And there's your flow. But what happens is you get a loop back from test to code because the defects start to pile up, and that interrupts the flow. You get a loop back from test to analyze with more defects because you realize that you didn't understand the requirements. And finally, you may get some loop backs from execute to analyze because maybe there's still a misunderstood requirement. So, what do we want to do? Always thinking testing. We're going to write a feature, and at that time, as we're writing a feature, we're going to write a feature test. We're going to write a story, and as we write the story, we'll write the story test. And definitely, as we write the code, we'll write the code test. In fact, we'll write the test before we write the code. And now, what have we done? We've shifted left. And we've shifted our testing left, thinking about testing at each phase here. So which is it? Is it shift testing left or is it shift left testing? Well, it really doesn't matter because you can't test something until you have that something. So we don't have the feature. What are we creating? We're creating the test on the left, not executing it because we obviously have the feature or the story before we can execute the test. So shift testing left, shift left testing, whichever you like. The key is that no code goes in until the test goes on. We're not going to write a single line of implementation until we have a test that tells us that implementation is working properly. So let's take a look at the flow then. We have our decide, analyze, all the way down to execute. And we've got three levels of test first. At the top, we have hypothesis-driven development. And there, the collaboration is between the product management and the product owner. And that goes from deciding to do something, and we actually run the test in production. And then we have behavior-driven development, the triad, the customer, developer, and tester. And that starts when we analyze the requirements and runs through the deploy stage. And finally, we have test-driven development, where a developer, a pair of developers, or a developer and a tester operate, and that's tightly coupled into the design and coding phase. So there's our 3 levels. Let's take another way of looking at these. Here is our current system. It's the as-is system. And we've got some story tests against it, which we'll have come up with behavior-driven development. We've got some code tests inside of there, which we developed using test-driven development. And now we have an idea for a feature, a to-be system. And we're going to come up with a feature test, i.e. whether that feature is actually the right thing to build, and that's going to use hypothesis-driven development. And of course, then we'll create some new story tests for our new feature, as well as code tests for the new implementation. So it turns out that tests and requirements are related. Every requirement should have a test. Otherwise, how do we know that we got the requirement right? And every test is a requirement. That is, if you cannot deploy a system with a failing test, then that test is a requirement. So it turns out we want to have our requirements before implementation so we know what to code to. We ought to have all our tests before implementation because they are requirements. And just to help you recall the relationship between the two, here's a little ditty. Tests and requirements, how they go together. You can't have one without the other. This is why I'm still in software. So let's start at the top with hypothesis-driven development. We need a benefit hypothesis that's going to validate our business value. And that hypothesis is something about whether the customer is actually going to use that functionality or not. It's a test of whether you're building the right thing. And what we want to do is create the minimum marketable feature, or MMF, the smallest possible thing to verify whether the feature has value or not. So we create an hypothesis. We build an MMF that is going to verify or validate that hypothesis. And now, when it's in production, we'll be testing it and evaluating and see whether people are actually utilizing it or not. Maybe they aren't. Let's stop any further work on the MMF. Maybe they are, and we're done with the MMF. Let's go to the next one. Or perhaps you go, well, that didn't quite work out. Perhaps we ought to pivot. Change our hypotheses, maybe. Change maybe our MMF. And see and try again. So let's give an example here of an MMF. A cruise control with the speed automatically set by the speed limit. And that speed limit is going to be determined by either GPS with a map, or maybe a sign reader, or maybe both. Well, it turns out autonomous vehicles are going to require this. Why? Because Elon Musk doesn't want to pay traffic tickets for every Tesla on the road. So now, let's come up with a little more detail. Given speed limit sign is 35, when the car views it, the speed is set to 35. That's our feature. So we need to create a benefit hypothesis with some metrics. Here's a template. We think that this capability will produce this outcome as measured by this metric. And for example here, we think that cruise control with a speed limit finder will be used by drivers 90% of the time as measured by telemetry. There is our benefit hypothesis. So what do you think will be the results? Well, if your jurisdiction is one that has speed cameras all over the place and large fines for speeding, we'll probably sell it and it'll be used 100% of the time. But suppose we're on a highway, you know where they are, with no speed limits, chances are nobody will use this. And in other places, maybe they will, maybe they won't. So maybe we need to pivot a little bit. Maybe we need to add the ability so that the driver can set the speed some amount over the speed limit. Now, Elon Musk will not be responsible for speeding because it's the driver who did that. Or perhaps we just display the speed limit and let people have a look at it. Or display a warning if over the speed limit. So we could pivot on our MMF. So now let's talk about behavior-driven development. Behavior-driven development. We create the test for the functionality prior to its implementation. And this ensures we're building the thing right. And who does this? It's the triad, the developer, tester, and customer, who are all responsible for the quality of the product. So here's a behavior. For a scenario, it's a flow. Set up, and that's the given, some current state of the system. Triggers the when part, we do an action or event. And then we assert, that's the then part, that we get an expected result. That's the behavior we want. And now we want to test for that behavior. So we set up the current state, we perform the action, and then we compare the actual results that occurred with what we expected. And it's either equal or not equal in a test failure. So let's look at BDD and ATDD. Here's a scenario. Given the car's speed is 30, when the speed limit changes to 20, then the car speed becomes 20. That's a scenario. And BDD focuses on that behavior. Well, it's going to turn into a test. And in the test, we simply check that the car's speed becomes 20. Now we also have acceptance test-driven development, which simply says that we are going to be testing the behavior. So in fact, it emphasizes the check, but the behavior is exactly the same in both parts. So ATDD and BDD are just slightly different views on the same underlying process. Any other behavior we want to specify? Well, once we have a scenario, we might come up with more like, well, how quickly does it change? At what point does it change? When we get to the sign, before the sign, how far after the sign? Let's take a business rule. Here is a speed limit that varies in the school zone. A speed limit of 35, and that's between those hours. So now we need to come up with some tests against that business rule. Given our business rule data, 7:45 to 8:45 is 35, so forth. Then let's run some tests for it. At 7:44, it's 45, because that's the speed limit for the road, and at 7:45 a.m., it becomes 35. But now we have tests, we can get into more detail of the behavior. Exactly when between 7:44 and 7:45 should it slow down? So we're always thinking test first. And one of the other benefits, it's easier to automate test written before an implementation to try and put automation on afterwards. So now, test-driven development, or as I like to also phrase it, test-driven design. And once again, we're always thinking test first. We do not test code, we code to the test. We create the test first and write an implementation to pass the test. So in test-driven design, our design allocates the responsibilities for passing those external tests that we came up with behavior-driven development to internal entities, components, classes, methods, and so forth. And so here's the cycle of TDD. It's much faster than BDD or HTDD. First, we code a test. We check that it fails. We write the code to pass the test, and just enough code. We make sure all the other tests pass. We refactor our code if necessary because it might have become a little bit messy. We check that all the other tests have passed, and then we start by coding another test. Well, let's look at an example here. We have our business rule for the school zone. We came up with some test. So we take that first test, 7:44 a.m., speed limit 45, and we make sure our code passes that test. And then we take the next test, 7:45 at 35. And we keep altering our implementation as we need to pass each test in sequence. And then, of course, we'll do even more and more tests, a whole sequence of them. And now we have an implementation developed by TDD. Let me just give one more example here, the speed sign processing. Maybe we have a sign head-on with clean text, and we try and pass that. And now we try recognizing a sign that's being looked side on, and then maybe one that has fuzzy text, or maybe one that's missing letters or has holes in the sign or something like that. So we slowly develop our implementation for that speed sign processing. So this is not an ending, but a beginning. What have we shown? Well, we've shown how story tests against the external behavior and code tests on the internal implementation of an as-is application. The feature test that we're deciding whether we're building the right feature with hypothesis-driven development. And those new story tests and new code tests against that new feature. So let's look at our flow again. What happens when we apply a test-first mentality? Well, we start to decide with our test. We're creating our hypothesis. We'll analyze with the test with BDD, which will help us design with our test to make our code testable. And as we're coding with those tests in TDD. Now, we'll still need a little bit of testing, but the most functional testing will have been taken care of. We still may have some performance testing or things that cannot be done on a developer's machine. We'll deploy with those tests. And finally, we'll execute with the test, i.e. gathering the telemetry to see whether a hypothesis passes or not. Well, with all these tests, what's happened? Well, we start to eliminate those loopbacks and get rid of that delay. We eliminate the loopbacks from test back to analyze, getting rid of more delay. And production back to analyze and still more delay. So your flow becomes this into this. So just to recap, we described how shift-left testing helps builds in quality, how loopbacks are reduced by shift-left testing, identified the different aspects of shift-left testing, the 3 levels, and the collaboration in HDDD, BDD, and TDD. So, did this session pass these tests? Go forth and shift left your testing. Thank you very much, and take care.